Hi everyone, welcome to this webinar here. We're going to get started in just a minute. We're right on time right now. Hopefully y'all can all hear me well, but we're going to be talking about how we secure the applications that we're making inside AI assisted programs. And today we're specifically honing into Windsurf IDE. I have created some apps on Windsurf. We have tested them for security, and we're going to be looking at what we need to do, what we need to know to kind of build apps securely. So welcome wherever you are joining. If you're on Zoom, if you're on LinkedIn, or if you're on YouTube, welcome. We're very happy to have you all here with us. Whilst people are still joining in, I'm just going to go ahead and get started. And those that are late, well, we will be recording it. They can now watch the start again from the beginning. But let's dive into it, so we don't run over time. And I give it. If you're wondering about me, my name is Mackenzie. I'm a security researcher and advocate at a company called Aikido Security. I'm from New Zealand, or Aotearoa, if you're wondering where my accent is from, but I live now in Holland, which is in the Netherlands, and I work for a Belgian company, just to keep everyone guessing as to where the heck I'm going to be in the world. And you can find me anywhere on social media at the handle @AdvocateMax. So if you want to kind of ask me a question directly, you absolutely can. I'll be on all the platforms around the place. So just to get out about the way, what is Aikido Security and why are we doing this? So Aikido Security, you wouldn't believe it, is a security platform. It's a security platform where we designed it for developers. And it's a security platform that will look inside your applications at various stages, from the first lines of code that you write all the way to its runtime environment on the cloud. And it's going to look at different security issues that you're facing. It'll do it in real time. And that's what we're doing. And so what we've noticed is that there's a large trend of people wondering how they can secure kind of the applications that have been made with assistance of AI. And that's what we're going to talk about now. It's not going to be very heavy on a product. And anytime I mention Aikido, I will mention alternative tools that you can use as well. So don't think this is going to be a sales pitch. But one thing I kind of want to bring up is that there's a lot of bashing about AI, particularly in developers. And if you're using something like Windsurf as opposed to kind of like a complete coding solution, or then you probably have some idea around development, and you're probably wondering the same thing. It's like, is AI coding good or bad? And here's this example of something I saw on Twitter that went really viral, where someone built an application using Cursor, a similar IDE, and they kind of had exposed API keys. They had their subscriptions were getting maxed out. Everyone was kind of attacking them, and so this is kind of the reality that we're facing. This is what we want to prevent from happening. But is AI coding good or bad? Well, it's neither. It's a tool. And this is why I like tools like Windsurf a lot, is because it's not really designed to kind of just generate something off a prompt. Other tools out there, Lovable, Bolt, they're designed for that. Windsurf is designed to assist you as you write this, but it does mean that you can get much further very quickly in your coding abilities and be able to create something really cool. So we need to understand how we can secure these. So we're not here to bash AI. There's enough of that on the internet. We're not here to do it. We're just here to secure it. And what I will say to everyone is security is a learnable skill. So if you're wondering, like, oh my God, and if you're kind of overwhelmed when you look at these giant programs that Windsurf is able to create, and you look at it and go, how on earth am I ever going to figure out what's happening? Well, security is learnable. So we can get there even if you don't have a lot of development skill, and that's what we're going to go through today. The first thing that I will say is what we want to do is we want to connect everything to GitHub. So when we look inside our Windsurf IDE here, this is obviously where our project lives. This is everything that we have. But what we also want is we want to connect it to something like GitHub, which is here. This is my project inside GitHub. And there's a number of reasons for this. One I found quite funny is this was on Reddit. It was posted 3 months ago, where someone was like, "Oh, their application built by Cursor, a similar IDE, got completely like blown up, and they had no way of like backing it up or going through versions." This is what Git is for, and Git, if you're not using it, is kind of totally essential for security as well because it gives a central place where tools can look into it. And when it comes to security, we absolutely need security tooling in place. A lot of it's free, a lot of it's open source, so you don't need to worry about it. But GitHub is the best place to kind of have these tools, have your code from it. And also so that we can go back in time so that if we do break something in our IDEs, that we can go back. So this one here, I found this Reddit post quite funny. You can imagine if you've been using Git, I'm sure you can imagine what the Git comments were. I mean, what the Reddit comments were in this. Yeah, this is quite funny. I kind of just wanted to start by that, to saying first point. I'm not going to talk so much about this, but the first point is that make sure we're using tools like Git. We're backing up, or we're in version control, and it's also where we're going to be able to connect a lot of security tools so that it can look inside our application and make sure it's not vulnerable. So, what do we need to be secure? So this is something that I kind of created specifically for people that may be using kind of AI-assisted tooling. And this webinar is mostly for people that maybe have some developer knowledge, but not huge amounts. And the two things that we kind of really need to secure are secrets detection and authentication or design flaws. This is where we're going to come into a lot of trouble in our applications. This is where I see where a lot of people that have their applications that they've built with AI, they have security issues. It's usually because there's authentication problems and because API keys and secrets are exposed. These are typically some of the easiest methods that an attacker can use to try and access your site. The next thing that we need to look at, and we'll look at in this webinar, is a bunch of different security tools that we need to implement. Don't worry too much. I'll explain what they are, but DAST, Dynamic Application Security Testing. This is like an application that attacks your site as if it is a hacker. And we'll look inside it. Software composition analysis. This looks at the dependencies in your project. We'll talk about that. Static code analysis. This looks at your source code, and then like firewalls that can come up. And these are kind of the last point of contact that an attacker might have. So these are kind of like your fail safes. There's a whole bunch of other things we can do here. Malware detection, end-of-life components, license protection. License protection in particular, this is kind of more like a legal risk, end-of-life components. There's other things. We can worry about those a little bit later. We need to focus on these first. And most importantly, if you're just going to focus on two things at the end of this webinar, these are the two that you need to focus on. And we're going to dive into that. We've got some demos here as well. So the first one is secrets detection. So what do I mean by when I'm talking to a secret? I'm not talking about trade secrets, because a lot of people can sometimes get confused. I'm talking about secrets like API keys, maybe security certificates, passwords, everything like that. That is what a secret is. And what's critical is that these are made to be used programmatically. An API key is not meant to be used by a human. It's meant to be used by a machine, an application. And this means that it has a high likelihood of ending up inside your source code. And there's a number of different ways that it ends up in there. The first one, and this is kind of what secrets look like. You have your encryption keys here, API keys, database passwords. You probably have all of this. Now, usually these are stored inside a file called a .env file. And in my case, yes, they are stored in this .env file here. This is just my database credentials as well. This makes this file very sensitive. What does this file mean? This is an environment variable file. When your application uses environment variables, when it uses secrets, it's meant to load them into a local memory. And it does this using environment variables. And that means that someone that's looking at your website can't see them, but your application, its backend, has access to them. And this file is what's used to load them in as environment variables. The problem is that this file is extremely sensitive. One of the biggest ways the applications get hacked is because this file gets exposed. And the biggest way that this gets exposed is through GitHub or Git projects. So I want to give you a concrete example of this. And this is kind of the first thing. If you don't have one of these in your applications, it's called a .gitignore file, then you absolutely need to have one. Now, in my case, Windsurf didn't actually create a file, a .gitignore file. So this was the first concerning thing when I created my application here. And I had to create one because it was preventing me from pushing this to GitHub. There was some large files in this folder that was throwing an error, so I had to do it. But when you have a .gitignore file, what it is it's ignoring things that are going towards your GitHub repository. So if we look at the moment, I actually have a pretty big risk here, is that my .env file is in my GitHub repository. Now, a lot of people fall by the wrong assumption that if your GitHub repository is private, then it's okay. This is absolutely not true. This is because Git, especially if you're working in teams, is designed to sprawl. Your code is designed to sprawl everywhere. And once this file is in GitHub, there's no getting it out. You have to remove all of the API keys. And here, what I mean by that is you have to rotate them from the source. You have to create new API keys or new passwords because these are all exposed. These are all done. So that is what's concerning here. And I was a little bit concerned that that wasn't created. But it does do a good job of creating one if you ask it to. So if you ask Windsurf here to fill out my, so I'm just asking it to fill out my .gitignore file. And then hopefully what it will be able to do is kind of, you should see it in here, is it's going to add a whole bunch of things, including a .env file and other areas like logs files. So here we can see it. And hopefully we have a .env file. Here we are. Yeah, .env file is here. It's also ignoring all log files. Secrets can be exposed in log files, all of this. This is kind of one of your first points of calls, and all of our environment variables files here. So we have to make sure we have one of this. An attacker, if you have a popular site or anything, one of the best ways that an attacker is going to try and target you is by targeting your GitHub repositories and your Git accounts. This is because they know your source code can sprawl easily. There's a large attack surface for this, and nothing sensitive is meant to be in GitHub, so the protections aren't usually adequate. So that's the kind of the first area. And how kind of secrets work, if you're still wondering, is that our application is kind of built up on all of these different services. So maybe you're using Algolia as a search function, Cloudinary to host applications. How your application talks to these is with secrets. So your secrets are really the keys to your kingdom. So we really need to protect them. The other way that they get exposed is if they are hard-coded. And this actually happens quite a lot with AI-generated code. I haven't been able to recreate this in Windsurf. I've tried a lot of things to try and get it to hard code an API key, and it hasn't. So that's a good thing. But that doesn't mean that that is not a risk. And so here you have our Stripe API key, and it's hard coded directly in here. This is a massive issue because this will be exposed. In this example, it will actually be exposed on the client side, so we'll actually be able to see it. But it also comes with the same issues of what we've been talking about before, of it getting inside your Git repositories and being exposed that way. So very, very important that we don't expose secrets. And secrets can be very easily found. If you want to play the role of an attacker, this is my site that I made with Windsurf. It's a news site. It has basic functionality like log in, log out, search for articles, read articles. And if you want to see if you can find API keys, what you can do is, whilst you're running your application, if you inspect the page and go to network, then what you want to start looking for things like API keys. I think we'll probably be able to find a couple. Not all of them are sensitive, but there's some different area. You'll be able to find different keys and things in that. And that's kind of how you know if your keys are exposed. But that is a very manual process. I wouldn't never suggest anyone relies on that. There are much better ways to identify secrets, and that's with something called secrets detection. So Aikido has a secrets detection module, and we have one specifically for Windsurf as well. But there are other tools that you can use if you want to investigate as well. Like Trufflehog is a great open source tool for detecting secrets. Same with Git leaks. So there's various tools that you can use. I'm going to give you a demo of how Aikido can find these secrets, and actually in two ways. So I'm going to switch back to my Windsurf IDE here. And what you'll notice here, I wonder if I can make this bigger. Yeah. Is we have done here an Aikido plugin. So we actually have an extension for Windsurf IDE. And if we go to our environment variable, you'll see that it's detected some keys, some generic API keys here. Now, in this case, It's actually a risk for me because my .env file is exposed, so it is a risk. But usually, if I did have the .git ignore, I could deal with these as well. But we want to make sure that we find them where we are. So if Windsurf did hardcode a secret, what's great is that at every point where a file is saved, Aikido will scan that in the IDE and identify any secrets that you have and notify you in your IDE. The next stage of this. So this is kind of like early stage detection, and this is great. This is what we want. We really want to make sure that we detect things like secrets as early on as possible, but we also aren't going to rely on that. So we can also use secret detection at other stages like in our actual application. So I've gone here to the Aikido dashboard. Now, again, you don't have to use Aikido. There are other tools. Aikido is free for you to use. I don't want to keep talking about it. We can also see here that we have these exposed secrets here. So we can actually, it's let us know that there's an issue. It's say that this is a JSON password field that's in base64 encoded and it's a high risk for us. And we can also, and it's actually looking at this from a GitHub repository. So this is an actual risk because it's actually been exposed. It's somewhere that it shouldn't. It's sprawled out. So this is something really important that we want to know. So just in our threat feed, we can actually see, and if we wanted to, we can filter just on exposed secrets too, and exposed secrets, it says here in our environment variable file. Actually, and we can also view the secrets where it's found them in in here. And actually, I've only just realized this, but Windsurf has actually hard coded some secrets. We can see one here. I'll need to investigate further, but I didn't actually realize it. I thought it was just referring to my environment variable secrets. I think it's actually hard coded a secret. We'll have to investigate that. Um, uh, to be investigated later, but secrets detection, you get it. I could spend literally the entire webinar, an hour, talking about secrets detection and all the different breaches that happen because of it. The last thing that I will say is that when you look at the breaches that happen that happen a lot, like actual ones. What you will notice is that where everything went wrong was because of a leaked secret. Now, they could have used sophisticated techniques to break into your network, to access your cloud accounts, to break into your Git repository. But where everything went wrong is that the attackers found a secret somewhere. That's typically how it works. Like the most recent example is XAI leaked some really sensitive keys recently that gave access to not only unreleased versions of Grok, but also privately trained models on Tesla. So they were able to get sensitive information from it from Tesla because they were trained on sensitive information. So when you see that someone getting access to your network isn't so bad, but then having a secret to there, it is. I'm going to stop talking about secrets now. But I really can't stress enough that you have to really make sure that no secrets are exposed in your projects. Now, the next part that is particularly bad with AI assisted applications is authorization and authentication. And I can also kind of relate these back to design flaws. I want to talk about design flaws because I think that's more fear on the tools that we're talking about is that it's a kind of a flaw in the design of the application. This is where I will for in every single tool I've used, I've done a lot of webinars on different tools. Every single one of them has authentication and authorization issues. So just to start off with, there's the difference between the two. Auth or authorization is what happens after you log in. So authentication is how do you log in? So what is the process that you do to log in? Is that login process secure? Authorization is what happens next. That is, what can I do when I'm logged in? So if you're logged in as a regular user, can you elevate your privileges to become an admin? So that's an authorization flaw. So if we kind of look at it is that, hey, we have here a user, he wants to see the email from user one. Is this person authenticated? Yes, then we can give him that. If it's not, then we throw an error. If we were to bypass that, that is an authentication flaw because we're bypassing the is this authenticated person here. And when it came to my site and specifically, I'll just switch back and give it. So we have some login areas here. I can log in as Mac. I have normal content and I have premium content. I know it's a little bit ugly, but to be completely honest, when I was when I was creating this, I had endless issues with authentication. My goal in creating this was that I wanted to give the tool as little assistance as possible. So this is a little bit unfair on Windsurf when I'm talking about this because I didn't write any code myself. I wanted to see how it dealt with just prompts. And when it came to authentication and authorization, it didn't do very well. I have three levels of user on this. I have a free user, which can access normal content. I have a premium content user, which meant to pay more. And I have an admin user, which controls everything. The good parts was that for authentication, it was using password hashing. So it did that with salting. It did that great. That means it's not storing your password in plain text. It's storing it as a hash or a high entropy string. It makes it very, even if someone was able to gain access to that password, they won't be able to actually review it, get back to plain text. It's a story for another day, but it's cool. We used environment variables. We had good input handling and verification and error handling. So that was good. The bad was that there was a lot missing from authentication right from the front to the back. There was no rate limiting. I had no password complexity things. There was no session security. So session security is kind of like when you log in, you get a session token. There needs to be logic around when that session token expires. So what that means is if you log back into Facebook, you don't have, if you visit Facebook again, you don't have to log back in, right? That's because there's a session saved on your machine that allows you to log in. But there are certain situations where you want that session to expire. They should all expire under multiple conditions. If this login is suspicious, if it's coming in from a different IP, if you logged in at the same time in different machines, all of these kinds of things. None of that was added in. We had no email verification and no MFA. The biggest thing for me, though, was that it was forever breaking. I would forever get errors, would be able to get on top of one error, and then it would break after that. Now, I want to be very clear that I'm not bashing Windsurf for this. This is something I've seen on all AI, and I was also kind of creating something quickly. But this was kind of scary to me that there was an awful lot missing when I think this should be pretty standard out the box now. I'll talk about that in a minute. So there was a lot of issues with authentication. The big issues, though, were with authorization. So it did manage to create me three different tiers, but under my sign up page, it like allowed me to create any one of them. So someone could create an admin. And I think the other thing was that if you just signed up as an account, it treated everyone with the same permissions. So if you could actually go to the admin panel if you were just a regular user. And so this was obviously the biggest flaw is that obviously I don't want a regular user to be able to go to the admin panel. However, this has happened. Now, this is a kind of a stupid example because I have a very simple application that I created in one day and going through. And you might think to yourself, well, of course you're going to have these issues. Well, actually, here's why it's an issue. It shows that the AI models don't actually understand the logic behind authorization. And that's completely fair because it could be perfectly reasonable that a random user can edit content. There could be you could want to create that in a site. So the fact that we can do that is kind of not necessarily such a big flaw. It's just that in my case, it's devastating. In my case, it's the end of my application because it will immediately get hacked. So this is the biggest issue that I have. Now, I could talk about how we can go on to authentication, how we can build secure authorization, how we can do all of these things. But my biggest advice to everyone out there is don't. Don't build your own authentication or authorization. And don't let an AI model build it either. There are entire companies that only do this. And it's because it's a very difficult, very important part of your application. Do not try and build it yourself and do not get Windsurf to try and build it for itself. So some out-of-the-box authentication services like Okta, Auth0. Auth0 is actually purchased by Okta. So they're different products, but they're the same company. And then we also have companies like Supabase and Firebase. they're a little bit different. So the top two just do authentication, and they handle it so beautifully, and they enable it so that they give you back, they give your users back session tokens to go with it. It's the process is seamless and flawless, and it's extremely secure. You're not going to be able to get better by yourself. And in most cases, there are free versions of this as well, or very low cost versions for low traffic sites. Supabase and Firebase are a little bit different. I will recommend these in a very specific scenario, which I'll talk about. But essentially, these are more than authentication. These also can handle lots of data storage, but they also do authorization and authentication as well. And I'll talk about that. I'll especially talk about Supabase because I think this is the best option for AI generated code. I'm not paid by Supabase. I have no affiliation to them. I just think that their product is the best for people that don't. If you're very familiar with databases and how that works and setting everything up, then great. You can go with something like Auth0 for your authentication and manage your own databases. However, if you're questioning about this, I would strongly recommend you lean towards something like Supabase for a reason that I'll talk about now. And that is something called row level security. And I'm spending a lot of time on these first two, I know, but I will go through other things faster. But these are kind of the biggest things I see out there as a security researcher. Now, what row level security means, or RLS, is it looks at your database on a row by row. So Firebase has something similar. They call it something different because Google has to call everything something different. It's called real-time database security rules. It's essentially very similar. What this is in a typical application, we have our database here, and our database is extremely sensitive, and we want to make sure that no one has access to our database. Who does have access to our database is our application, and we have to have all this logic in our application to ensure that no data is exposed that isn't meant to. So if we have our entire database here, our application has access to the entire database, and we have a user that says, hey, show me the data from user one. Now, we'll check that they have permission for that in the app. We'll go through a whole bunch of series, and then we'll give them back the data for user one if they're allowed to view it. But all of that logic is in the application. If we trick the application by doing something like SQL injection or something, and we pretend that we're an admin, and I'm saying, hey, I want you to show me all the data for everyone, then the application will do that if it thinks you have the permission. This is where row-level security is different. Row-level security, we can actually expose our entire database to anyone. And that is because we have security policies that are written on a row-by-row basis that only allow people to access it like in certain circumstances. And as far as the application is concerned, the application doesn't actually have access to all the data. The application only has access to the row that the user has access to. So the application can't be tricked. If we went through the same scenario where we tried to trick the application, show me all users, in the case of row level security, the application would only think there's one row in that database. That's why this is better for AI, because it's much easier to manage, and we don't need to understand in depth all of the logic that the AI tool has created to enable us to be secure. We can just write policies for ourselves. And these are what the policies look like. And it's what I would more or less call declarative, which is where you can kind of declare the policies that you want. So here are three policies that are in conflict with each other, but you wanted one. So in this scenario where I had a social media site and I wanted everyone's profile to be viewed by everyone, I would just write this policy. And it would work it out on row by row. If I wanted a policy where only authenticated people could view profiles, I could do this. And what that would mean is that now all the profiles aren't viewable to the public. No search engine can see them. No random user can see them. Or you could go more extreme and say, I only want to be able to view my own profile, no one else's. And then we can do that. We don't need to change any logic in our application. We don't need to change anything. We can just simply write the security rule and it will deal with it. So this is what's really good. And these security rules are quite easy to understand once you get your head around it. So I would really recommend looking at something like Firebase or Supabase that has these kind of security policies where it's denied by default, and it's a much more secure way of doing it if you're not understanding the logic behind it. Okay, so that's the first two. That were the most important ones: secrets detection and authorization or design flaws. That's where most things kind of go wrong in AI generated apps. Next, we need to talk about is something called DAST, Dynamic Application Security Testing. And what this is this is kind of like a hacker inside a box, where an attacker, where you have a product or a tool that's going to be attacking your website like an attacker. And it will look for certain vulnerabilities like injection vulnerabilities, cross-site scripting, authentication. It will help you find authentication issues by trying to elevate its privileges. It will find security misconfiguration, sensitive data, and it will look at that. And what this does is once you have your application exposed on the internet, or you can do this locally as well, is it's going to then visit that website and then do a whole bunch of security testing for it. So if you're looking for DAST tools, of course, Aikido is one, but there's also some free tools. Zap is free, Nuclei is free. They're both open source that you can use on your site as well. And what I'll show you is how that looks like is that we actually go into our site here. I connected my site to this area here. And it's done a whole bunch of series of checks. So you can see all the checks that it's doing here and how it's doing them. And it will also check things like your REST APIs, your front end, or if you're using something like GraphQL, it can check all of that for you. And it can also authenticate itself. What that means is that if you give it a login detail, it can log in as a user and see if they can elevate their privileges to an admin. So it has found some issues with my application right from the back. The first one that is found is that my CSP header, my content security policy header is not set. This is really important in a way to prevent malicious scripts being run on your site. It's probably the most important thing to prevent something like what we call cross-site scripting. So an example of that is recently I found a bunch of images that were hosted somewhere that other sites were using, but inside those images were malware. And they could get the application to actually run the malware in the image. A CSP header would actually prevent this. I can guarantee almost that your application, if generated by Windsurf, won't have a CSP header. But Windsurf is quite good at generating them. So again, we can just simply to ask it, is that... Oh, machine. There we are. And then it will run through and create that process for me. And it deals with it really well, in my opinion. So it's going to create a middleware file to implement content security policy header for me. So this is kind of, yeah, it's going to do this and add it in. And then once we redo that scan, we won't have that error anymore. So that's really great. And if you're wondering, if I look at this, how do I know what to do? Well, in Aikido and other tools as well, they usually have a how to fix thing. And all you need to do is just copy that how to fix and just paste it into Windsurf. And it will solve that and help solve that for you as well. All right, we need to move along because I'm running behind schedule, but there's something else very important that I do want to get through, and that is called software composition analysis, or SCA scanning. So something that you probably don't know is around about 85% of the code on your applications come from open source components. And I'll show you exactly where these are and what they do. But basically, when you go to your site, it's doing a whole bunch of things. How it interacts with your database will be from an open source component. How it deals with the different dynamic components of your site will be from an open source component. And only about 15% is what your AI tool or what you write yourself. The rest is all comes from open source. And this is kind of the state of the world, but it's really important to understand this because if an open source component has a vulnerability in it, that means your application by proxy or by association has the same vulnerability in it in a lot of cases. So if we look at it, we have our application. We're going to use a bunch of open source dependencies. And we can see some of these dependencies that we have. If we go back into our application here, if we go into our file, you should have something like a package.json file. And if you look here, let's see if I can move this to the side. And if you look here, you'll see a few of these packages that we have. And it doesn't look like we have a lot. And these typically fall under what we call our direct dependencies, which is this first layer. But the problem is that these direct dependencies also have dependencies, and they also have dependencies. And for about 30 layers deep, we can keep going. We can actually see all of these dependencies, because when you compile your application, it actually puts it in a file called a package lock.json, which is the one that's just above this. And our other file, the package.json file, was quite small, but look at how big this one is. It's thousands of lines of code, and each one of these is a dependency that we have. This is something that's making our application run. There's thousands and thousands and thousands and thousands of them, and you will be able to see them in your own website as well. Okay, so nearly 3,000 lines of code. We've probably got about 500, 600 different dependencies that we're relying on in our application. Now, the services that we use also, if we're using something like Okta, like Cloud and Area, they also have open source dependencies. So what can make it confusing is that you can it turns into spaghetti where you have open source dependencies that are dependent on each other. You have third-party services that are dependent on dependency. And why this all matters is that let's say there's one dependency down here, this little red dot, that has a big vulnerability in it. Now, if you were familiar with coding, in 2020, we had a massive issue, or maybe 2021, we had a massive issue called log4j, and that was one of these dependencies that was in almost everything was turned malicious. And then what happened is everything upstream from that also turned malicious, which meant that most sites on the internet had this big critical vulnerability in them, remote code injection vulnerability, because this little dependency down here had that vulnerability inside it. And this happens an awful lot. And there's multiple kind of different attack paths that attackers can use to do this. So the first one is kind of targeting known vulnerabilities. So when you're using these open source dependencies, attackers can find out which dependencies you're using and then run kind of almost programmatable attack paths on them, because the vulnerability is known, how to exploit it is known. So it's very easy to test that in your application. So Log4j I just talked about was a big example where people are targeting known vulnerabilities that they're out there. There's something called dependency poisoning. This is when a popular dependency is turned malicious intentionally. So the Log4j issue wasn't intentional. Just these packages, they have vulnerabilities in them, and when people discover them, they report them, and then people can attack them. When something's poisoned, it's because someone's stolen access to a dependency, or there was a really famous case last year called XZUtilis, where someone spent years pretending to help on a project so that they could become trusted in the community, which was for this project, and then they injected malware into it. And this was another example where almost the entire internet went down, because this is another thing that's in almost everything, and the malware they put in there was horrible. And then another one which you don't have to worry about too much is something called typo squatting. It's where people will create a package that looks similar and hope that you make a mistake. Luckily for us, AI don't really make spelling mistakes. That's not the type of mistakes that they do. But if we give an example, here's an example of a dependency that was poisoned. It was called UA parser. It did something simple. It let you know what library it would let you know what operating system or device you were viewing it. So if you wanted this information and you said to Windsurf, I want to know on what devices are my users viewing my application on, it would probably use UA parser. It's a very popular application. It has lots of version history, but the problem was it was hacked. So an attacker managed to gain access to where it was being hosted. It was being hosted on a site called NPM. And the attacker then sold it. They sold it on the dark web. They sold access to this account, and then someone bought it and then installed crypto miners and credential stealers on it. That meant that if you were using this version of UA parser, you now had a crypto miner and a credential stealer inside your tool. So this is really quite scary. Another example of this has happened recently where the official SDK for Ripple, which is a cryptocurrency, the sixth largest cryptocurrency, the official toolkit was hacked and malware was installed. This was the malware. And what that malware did was it stole private keys for crypto wallets. What this meant is that if you were building a cryptocurrency exchange, for example, and you were using this package, which you would have been, I can almost guarantee it because it's the official package to communicate with the Ripple ledger, then all of your customers' private keys would have been stolen and all the cryptocurrency would have been stolen. So you probably wouldn't have had a business the next day. Luckily, we actually found this in the Aikido research team. We found it 10 minutes after it was published. So we were able to prevent a lot of damage, but this could have been catastrophic. So this is kind of a few of the things that happen that we're talking about. So how do we deal with this? Well, there's a number of tools that we deal with this, and they're called SCA tools. There's tools like Aikido, Dependency Check, Dependency Track, and Trivy. And I'll explain kind of how these work. Is that when a security vulnerability is discovered or malware is discovered, it goes into a big database. The main one is called NVD, the National Vulnerability Database. And essentially, we have these tools. I'm going to go back to my file here that look at the name of the package, which is this. They look at the version of the package, and they check in the database to say, does this version of this tool have any known vulnerabilities in it? And if it does, it lets you know. And it does it for everything. So this is really important in understanding and what we have. And this is kind of tricky because this particular issue, you can do everything right and you can still be vulnerable to this. And what will typically happen is, like, let's say your application is running and you change nothing. You don't release a new version because everything's running smoothly. What can happen is that one of these dependencies will be discovered to have a vulnerability inside it. Then it's reported. On your end, nothing's changed, but now you have a known vulnerability on your application. So this is something that even if you don't update your site a lot, you need to make sure that you're familiar with how these tools work. So in the case of my site, when I found with Windsurf, is we can actually look inside this. If I go back to our feed and we go into open source dependencies, we had a critical one here, which is a massive one, which is the Next.js. This had a critical vulnerability inside it. And it actually has multiple vulnerabilities. So it has one critical, which is the highest, and it has multiple high vulnerabilities. And so this is a very outdated package that Windsurf actually used. So and how do we fix it? We need to upgrade to the latest, to a newer version that doesn't have the vulnerabilities inside it. At the moment, we're vulnerable to a number of different things, including server-side request forgery, and abuse of authorization. So there's a number of different things that we're vulnerable to here. So it's pretty concerning that we're seeing that. When it comes to this types of tool, you do typically get a lot of noise in this, meaning that issues that you don't typically see with other tools. I'll give you an example of that. Is if we look at a bigger, more complex project here, you see we have lots of these, but actually we have auto ignored a huge amount. And if we have kind of a look at this, what you want to make sure is that when you're choosing a tool for SCA, that it has something called reachability, and that is actually that it tests via, like, looking at your source code, it validates and analyzes that are you actually vulnerable to that issue? Are you actually vulnerable to that issue, or are you using that? So, because sometimes you can be using a dependency that's vulnerable to a function, but if you're not using that function, then you're not vulnerable to it. So it gets pretty complicated. I hope I'm not overwhelming you all much too much here. If you use tools, you don't need to worry about it too much. All you need to do is find out what you're vulnerable to, copy this how to fix, and give it to Windsurf, and it will upgrade it. Now, sometimes upgrading to the latest package can break a lot of things. It can affect functionality. So it might cause a lot of pain, but I can guarantee it'll be less than the pain that will cause from a breach because of it. I can guarantee it. One of the last areas that I want to talk about is called static application security testing, or SAST. And this is actually looking inside your code for coding issues that are vulnerable. One of the things that AI tools are not great at is things like SQL injection inside your DIRs and inside your code. And the reason why they're not great at that is because with things like SQL injection, it's when you're taking untrusted data, usually data from a user, and you're using it within a function immediately. And that means that if the user puts code inside that untrusted data, then that may run that code inside your function. So these are injection vulnerabilities, and these can be really, really bad. the AI tools aren't good at that because they aren't good at identifying relationships between data input and data use. That's why. There was no big injection vulnerabilities or anything found in SAST from Windsurf, which was good. But what it is looking for is insecure functions that are being used, input validation issues, access control flaws, or any like sensitive data exposure. Now, what's great about Windsurf is that again, Windsurf, we have an IDE plugin, our Aikido plugin, and we can actually check for coding issues inside your files. So we can check inside them to make sure that are there any issues that we have? And as you can see here, we haven't found any coding issues that we have inside our application. And what's great about that is that we can actually see it immediately. As soon as the code is updated, we can get a notification inside our IDE, inside Windsurf to say, hey, here is an issue with security that we need to deal with, and we can deal with it immediately. But there are also, as with everything, oh, how do I get back? There are lots of other tools to use as well. There's you can look at lots of free open source tools to try and use for SAST scanning as well, and you can also have a look on Aikido. I'll go back to the feed. This is in a kind of a bigger application. If you look at just SAST issues, you can see some of the issues that you see here, and you can kind of take a look at what it's actually doing it. And it's an injection vulnerability because we're taking untrusted data into it. So we can identify all of these different coding issues immediately, either with a tool that's looking at your GitHub repository or directly in the IDE if you're using something like Aikido. All right, I have one more, and then we'll get to the wrap up. But the last thing I want to talk about is kind of your last point of failure, which is firewalls. There's a couple of different types of firewalls that you can have. You have web application firewalls, or WAFs, and you can have something called RASP, Runtime Application Security Protection, I think, or in-app firewalls. And what they do is they kind of look at traffic and area coming into and requests being made to your application. And if an attacker makes a malicious request, it can actually block it, along with blocking known IPs of attackers or bot farms or areas like that. So they're really quite important. The most popular one is Cloudflare. That is a WAF. And then if you want to go something that has deeper protection, you can use something like Zen, which is an in-app firewall, and it's able to identify traffic and movement between your applications. So I would really consider something like this because these are kind of a fail-safe. So if something slips past, if Windsurf creates something that's vulnerable, if there is some mechanism that isn't working well, this firewall will not only stop attackers, it will actually stop their attacks as well. So I really recommend everyone that's building something with AI to make sure that you have some kind of firewall in there as well. So the last thing I kind of say is AI coding tools aren't going to replace developers in the same way calculators didn't replace mathematicians, but they are going to be used every day by them, right? I'm pretty sure most mathematicians will be using calculators nowadays, right? And I think and there's no point discussing whether AI is good or bad because AI is here to stay. And what I love is that whilst it's going to change how we develop, and we need to, and it's creating some difficulties right now because there's some moving, growing pains, and that is that security is often being left behind. But security is a learnable skill, and there's a bunch of tools out there, a bunch of free tools out there as well that you can use for this. So just lastly, what do you need to do? Most critical, secret detection and authorization or authentication issues. This is absolutely what we need to focus on for the first two. Make sure you don't have any secrets in there. Make sure your authentication workflows are done. And please, please, please don't try and write your own authentication. It's only at some point, if your site gets big enough, you're going to have to rip it out anyway. So it's best to put it in immediately. Then there's this bunch of tools that you should implement to make sure that your site's secure at every stage. Scan your site itself with DAST, look at your components, scan your source code, and then install a firewall. And if you've done all that, then give me a bell and we'll talk about these ones back here. But these are kind of something to worry about later on, but your journey in security will always continue. So that's it for the webinar. If you go to the Aikido blog, which is aikido.dev/blog, you will find something called the Vibe Check, the Vibe Coders Security Checklist, which is a little checklist that I wrote that goes through a lot of these points, but in a more bit by bit, byte by byte kind of manner to help you identify what you need to do for security. So I hope you found the webinar useful. It is a recording of it will be sent to you so you can watch it again. And I hope that you keep in contact with myself and Aikido to know when the next webinars that we're doing are coming live and to check out some of the other content we have. So until next time, thank you for spending this time with me. Thank you for tuning in, and I wish you all the best.